Okay, today we get to do 1/6, compound and absolute value inequalities. First, we'll start with compound inequalities. There's going to be two types, and or. So first, let's talk about and inequalities. An and inequality is going to be true where they're going to give us two things here, and it's true where your answer is where both of those are true. So for example, if I told you to go buy a yellow fruit, okay, and you went and bought corn, did you follow the directions? No, because corn is a vegetable, even though it's yellow. Then if you went and you said, and you went and bought an apple, did you follow the directions? You bought fruit this time, but it's not yellow, assuming it was like a Red Delicious or something. So maybe you went and bought like a banana. Yes, now you have followed directions because it was a yellow fruit. So the answer is going to be shaded where both of them are true. So check it out. What I'm going to do is start by doing a number line, and whatever two numbers are your answer, if you were like actually solving this, go ahead and put those on there. So individually graph each answer, only using arrows for now. So like x is greater than -4. That's going to be a dot. Remember, extra ink, extra ink. Oop, that was the wrong line. Here we go. And it says x is greater than -4, so shade this to the right, but only do the arrow for now. Now do the same for the 3. This one's a circle, and it's going to go to the left. So now we have to shade where they're both true. If I come over here to like this side, they're not both true because the -4 doesn't work. If I come in the middle, they're both true, so this is where I'm going to shade. And just to double check, on this side, are they both true? Nope, the 3 doesn't work, so I can't use that. All right, so now we're going to actually have to solve something. Just to write this is by putting in one problem like you see here on 1A. Now what you should know is how to divide this is the first part on the left side of that less than or equal to sign. That's going to be your first one. So let's write that down. -12 is less than or equal to 4x plus 8. Now your second inequality is the other half on the right side of the first inequality there. So let's write that down. 4x plus 8 is less than or equal to 32. Now solve each of these using all those awesome skills you've already learned. Whatever you do to one side, you have to do to the other. Whoop, hang on, did you multiply or divide by a negative? No, so you do not have to switch the sign. That's good. All right, over here. What is that, 24? Check that out. X is less than or equal to 6. So now I'm in the same spot that I was on that first example here, where I can now graph it. -5, 6. Let's see, it looks like this one's a dot. X is greater than the -5. 6 is less than, or X is less than 6, so it shades this way. Is it true here? No. In the middle? Yes. On the right? No. Okay. By the way, let's say that these graphed like this. This is just a random example over here. It doesn't really matter here. Just shade where they're both true. So in this example, not true here, not true there, yes, true there. Okay, so that's what that one would look like. Now we get to try or inequalities. So this time, I tell you to go to the store and buy a yellow fruit. And if you purchased a banana, that is a yellow fruit. Oh, no, I'm sorry. I said buy a fruit that is, or buy something that is yellow or a fruit. So if you buy an apple, that was a fruit. Even though it's not yellow, I said or. Then if I said, or if you bought that corn, it's yellow this time, even though it's not fruit, but I said or, so you're good to go. If you bought that banana, you're still good to go. Even though it follows both, that's still fine. If it follows both directions, good, as long as it follows one of them. So with these ones, again, you're going to solve it individually. And I'm just going to divide by 5. Uh-oh, I'm dividing by a negative. What should I do? Change the sign. All right, so I have -7 and 3. And it looks like -7 is a dot. It says J is, oh, whoops, what happened? Here we go. J is less than. And it says the 3 is a dot and it's greater than. So now just ask yourself, on each of these 3 parts here, is it true for anything? So is it true for anything here? Yes, it's true for the 7. Shade it. Is it true in the middle for anything? No. Is it true on the right for anything? Yes. So shade it. All right, random example time. Let's say that you graph it and it looks like this again. Is it true for anything over here? No. How about in the middle? Yes. How about on the right? Yes. Check out this crazy example I'm about to do. What if they shade like this? Is it true over here? It's kind of tricky to see, but yes, this one is going to keep shading all the way over here, just like the one on the left is going to keep shading all the way to the right. If all the numbers are shaded, our answer is all reals. By the way, if you don't want to write all reals, you can do this symbol. That means all reals. I meant to show you back up here on the ands. What if it's shaded like this? Oops, I'm sorry, wrong direction. Shaded like this. Remember, it's an and, so you have to follow both directions. Does it follow both of them on the left? No. Middle? No. Right? No. The answer is no solution. All right, so just a really fast peek then at 3A. Or here we have these absolute values. Basically what you need to know is if it's an and, or I'm sorry, if it's a less than symbol, that's going to make it an and inequality. And if it's an greater than symbol, that makes it an or inequality. And so you solve this the same way you do the absolute value bar ones, like the equations, where it was like you write it down twice, but on the second one, you switch it to a -6. What you should also know with inequalities is I'm also going to switch the sign. So now I have -6 and 6. And it's going to shade in the middle. Whereas this one over here has, it's going to be t is greater than 3, t is less than a -3, -3 and 3, a couple of circles here, -3 shades to the left, +3 shades to the right, like so. Okay, now if you remember from your absolute value equations, sometimes it had an equal or a negative on the right hand side of that equal sign. So what if it looked like this? Do yourself a favor. See this negative sign here again? If you see a negative sign, stop and ask yourself. The left side will always be a positive number, less than a negative number. When will a positive number be smaller than a negative number? Never. Positive numbers are always bigger than negative numbers. So this is no solution. Okay, if I try it the other way, oops, let me try that again. Greater than -6. When will a positive number be bigger than a negative number? The answer is always, so it would be all reals. All right, we're going to have a worksheet and Delta Math today.